Okay, so our last example here, this one looks kind of crazy. We're supposed to do another sigma notation, but notice what we are adding up to here. What's our last one? That crazy sideways 8, we know that's infinity. So how in the world are we supposed to add up to infinity? How do we do that? Well, what we want to recognize here, first of all, is this arithmetic or geometric. We have an exponent, so we know that this is going to be geometric. Okay? Now, with geometric series, we can actually add up to infinity. And what we want to pay attention to here is this. You might think, well, if I'm adding up an infinite amount of numbers, wouldn't that always add up to infinity? Well, let's find out. Let's kind of go through an exploration here. Let's find a sub 1. Okay? So that means we have 2 times 1/2 to the n minus 1 power, 1 minus 1. Well, 1 minus 1 is 0, and anything to the 0 power is just 1. So my first term is 2. Let's go ahead and find out what's the second term. 2 to the times 1/2 times the 2 minus 1 power. Well, 2 minus 1, that's 1. So we have 2 times 1/2 to the first power, but 1/2 to the first power is just itself. So what's 2 times 1/2? That's 1. And then we have a sub 3. 2 times 1/2 to the 3 minus 1 power. Well, 3 minus 1, that's 2, and 1/2 squared, I'm squaring both the numerator and denominator, so that gives me 1/4. Well, 2 times 1 over 4, that's going to be 1/2. Let's try a couple more here. A sub 4, 2 times 1/2 to the 4 minus 1. 1/2 to the third power is going to be 1 over 8. 2 times 1 over 8 is 1 over 4. Okay? So now what I want to do is I want to go ahead and keep going here, but I don't want to keep doing this, but I want to see that these numbers are getting smaller. And so what's going to happen is we get bigger and bigger and bigger, right? So let's look at what would the 20th term here be. Well, that's 2 times 1/2 to the 20 minus 1 power. And what is that? So let's go ahead and look at our calculator and try and punch this in. So we have 2 parentheses 1 divided by 2, that's my half, to the 20 minus 1 power. I'm just going to do that part in my head so I don't have to worry about order of operations. So 2 times 1/2 to the 19th power. And we see that's 0.00004. Okay, so that's a number really, really, really small. Let's go ahead and take a look at what would the next one be. Let's think about something else that would be really, really big. Okay, let's try the 200th term. So if I were to plug that into my calculator, I would have 2 times 1/2 to the n minus 1 power. Well, if my n is 200, then 200 minus 1 is 199. Oops, I obviously made an error there. Let's go ahead and delete that, and we'll try this one more time. 2 times 1/2 to the 199th power. There we go. And we get 2.4892 e to the negative 60. So that e to the negative 60, what it's telling us is move the decimal 60 places over to the left, which means 0.000000000000000, lots of zeros, and then finally a 2. So effectively, if we have a whole bunch of zeros in between our next number and the decimal place, what is that number? It's going to be effectively 0. So what this tells us is this number was very, very small, right? We had 5 zeros, 1, 2, 3, 4, 5, and then a 4. And then a sub 200 was 2 times 1/2 to the 200 minus 1. And that number was 0.00000, on and on and on forever. Effectively, at a certain point, we're not adding anything anymore. We are adding zeros. So here's what we can say. As you add more and more terms, each term gets smaller. And effectively, what you're doing is adding 0. So if at some point we're going to just keep adding 0 a bunch of times over and over and over again, it doesn't even really matter. Okay, so we actually can find an infinite sum because at some point we are going to be effectively adding 0. We can now use the sum for an infinite geometric series is going to be following this formula. A sub 1 divided by 1 minus r. This is the sum for an infinite geometric series. Okay, so make sure we've got this in our notes, and then let's go ahead and apply it here. Our a sub 1, our first term we found was 2. Our common ratio every time we were multiplying it by a half, right? So let's go ahead and plug that in. Our s sub infinity is going to be a sub 1, 2, divided by 1 minus my common ratio. Okay? I don't even need a calculator for this. I can do this in my head. This is okay. My denominator, 1 minus a half. Well, that's 1 divided by 2. Now, how do we divide by fractions? We multiply by the reciprocal of that second fraction. 2 times the reciprocal of 1 over 2 is 2. And my infinite sum then is 4. So if I were to add up all the numbers in that series, eventually I'm going to get to 4, and it's never even going to change. So you can actually still even find sums of infinite numbers of terms. Okay? So not every time is it going to work out like this that you can use this kind of a formula. It only works when you have a common ratio that is a fraction. That is the only time this is going to work. Otherwise, you are going to be getting essentially up to infinity. Okay? So that's it. Go ahead and take a look at your assignment and get started. Thanks for watching, guys.